And we'll get started then. Good morning, everyone. My name is Clark Ballou Crawford. I currently work as an energy management specialist within Columbia Water and Light's Utility Services Division. Our main responsibility is to manage and implement a variety of energy efficiency programming and to facilitate energy efficiency upgrades for both residential and commercial customers. Today I'll be talking about the nuts and bolts of a similar energy efficiency study that Sarah had talked about, but one that was here in Columbia, Missouri that we undertook with MEI. I'll kind of talk about the nuts and bolts of that study before I turn it over to Travis Wood to kind of expand on that. So next slide. So for those unfamiliar with Columbia, Missouri, we're the quintessential college town. We have 3 main campuses here in Columbia with several different smaller satellite campuses. So all that is to say is that we have a lot of renters, a lot of students coming in year round. Our population is about 120,000 people, and of those 120,000, it is estimated that about 53% are renters with an average tenancy length of only about 10 months. With them being such a major part of our market, obviously, we need to penetrate that area and see where we can't help both the tenants and both the property owners to make those their properties more efficient. Another piece of important information is that the City of Columbia implemented the Home Performance with Energy Star program back in 2008. This program helps to bridge the split incentive gap that Sarah had touched on, where tenants don't see a benefit to spend money on a property that they're not going to stay in for very long, whereas owners don't see that benefit for a property they don't pay the utilities on. So this Home Performance program, we help we offer rebates for adding things like attic insulation, replacing heating and cooling equipment, insulating ductwork, things like that nature. Next slide. All right, so where did we get started? So the first thing we decided to do was that we gathered all of the homes that participated in our Home Performance with Energy Star program in 2017. We used that as the control year. There was about 600 to 700 total houses that went through the program that year, and of those, about 60 were rentals. We went through all those different rentals, and we whittled the list down to about 30 based on a set of different criteria. The biggest issue with a lot of the rentals were there was gaps in utility usage. So, we were comparing usage prior to improvements and post improvements, and that makes it hard to do if, there's nobody living in that unit for 4 months out of the year when we're looking at that. So that's the biggest reason. But anyway, we ended up with 30 total rental properties, that we looked at. We then gathered raw electricity and available gas usage data for the years before and after, so 2016 and then 2018, so pre-improvements and post-improvements. And then in order to standardize for differences in weather between comparison years, I used a usage per degree day calculation that we'll get into a little bit more on this next slide. We won't spend a whole heck of a lot of time on it, but we'll kind of cover it. So next slide. All right. So to standardize for weather differences, we first researched how many combined heating and cooling degree days were in each comparison year, so 2016 and 2018. We then divided the total usage, so either kilowatt hours or gas CCFs, by that number to get a usage per degree day number. What we then did was took the average number of degree days in 2016 and 2018 and multiplied that usage per degree day number by that average number of degree days. And that's how we came up with the normalized kilowatt and kilowatt hour usage, as well as natural gas CCF usage for the properties that we had available. Next slide. So before we get into the results, here are a couple statistics that give a general idea of what types of properties participated in the study. One of the limitations of that home performance program is that only single-family homes, duplexes, and townhouses can participate. We don't currently offer rebates for multi-level apartment buildings, which is a good chunk of our market that unfortunately we haven't been able to penetrate yet. But for this study, like I said, we're going to be looking at both single-family and duplexes and townhomes. Of the properties we looked at, 47% are older than 1960, and only 13% have been built in the last 20 years. So it's obviously going to be a little bit older, skewed data, but we anecdotally felt that that was accurate for the rentals here in Columbia. And then as far as building footprint, only 23% of the properties we looked at measured larger than 1,500 square feet. So most of them are going to be obviously pretty small, which is consistent with most duplexes and rental properties that tend to be quite older. So next slide. So we can go ahead and jump into the results now. On average, the studied properties saw realized utility bill savings of about $318 annually. That figure combines both electricity and natural gas expenditures, so that's across the board. We used an average cost of 11 cents per kilowatt hour. Columbia does have a tiered electric billing system, but for most customers, 11 cents is going to be a pretty good average. And then we used an average of $1 per CCF of gas, just to make it a good round number. I know that fluctuates quite a bit depending on time of year, so we had to pick something, but of the 30 properties studied, 20 saw a reduction in usage after improvements were made to their dwellings. Next slide. Moving on to just electric savings, since we are an electric utility, we did have a lot more of that information than we did natural gas data. We studied, like I said, 15 single-family homes and 15 attached homes, so we do have a good combination of both. Savings were much higher for single-family homes than they were for townhouses or duplexes, something that is to be expected with just the fact that single-family homes tend to have higher usage overall. You know, they're not attached, so they're going to have to heat and cool quite a bit more than what the townhouse or duplex was, so that was to be expected. Anecdotally, I can also say that many of the single-family homes were older than the duplexes and townhomes. You know, a lot of our affordable housing, if it is a single-family home, is going to be from, you know, the 1920s and 30s compared to the newer duplexes here in town. So that could be another reason that those single-family homes saw such a large improvement. Next slide. So as this translates to actual electric usage, the single family properties saw an average reduction of about 3,800 kilowatt hours annually, whereas the attached properties saw a reduction of only about 1,500 kilowatt hours on average. So still quite a bit considering the less usage that they do see over the course of the year. Next slide. So as far as what improvements were made to each property, we can look at the following graphs. The only upgrade that was done by the majority of the properties was adding attic insulation, which was done by 83%. The attic insulation is kind of a low-hanging fruit upgrade. It has a quick return on investment compared to many others and a low upfront cost, so it's a little bit more palatable for property owners. All other upgrades that we offer rebates for, like replacing windows and doors, replacing heating and cooling equipment, and insulating ducts in unconditioned spaces, were done by less than a fourth of the properties that we looked at. So next slide. So now one of the common misconceptions we do hear in this line of work is that in order to reduce usage drastically or even enough to make a difference, that owners must spend an exorbitant amount of money on property upgrades. Which doesn't necessarily have to be the case. If we look at this graph here, of the studied properties, only 17% of owners invested more than $5,000, and almost all of those were heating and cooling systems. I think there might have been one or two window and door jobs, but mainly heating and cooling equipment. 53%, so over half of the properties invested less than $1,000. And so again, that's going to go back to those kind of that attic insulation, that air sealing, those cheaper things that can make a large difference. Next slide. So lastly, we'll go over some main takeaways from this study. First off, the major one is that 20 of the 30 properties we looked at did reduce their usage, something that we considered impressive with the massive amount of tenant turnover and other factors that make studying this rental market so difficult. As we alluded to in the last slide, it's also fairly evident that many of these properties don't need to see a massive investment to see a difference. One thing I like to tell property owners is that picking off that low-hanging fruit is certainly better than not picking any fruit at all. And that it does make a difference. Lastly, I would say that this case comes with the caveat that further studies are definitely needed to fully understand the impact of efficiency upgrades on rental properties. Due to the limitations in property data and workforce, we were only able to examine a small set of data, 30 houses, which again, it's better than nothing, but obviously we want to expand that whenever we can. As we move forward, I think examining the impact that these upgrades have on tenant satisfaction, how they affect tenancy length and retainment, and if they are able to increase tenant financial stability, would be valuable routes in understanding the true value of energy efficiency. I know that Sarah had kind of touched on that, but here locally, we have not dived that deep into it. So, but I would imagine that our results would mirror hers as well, that those are another major benefit to these as well. So thanks for listening, everyone. I'll now turn it over to Travis Wood to further expand on this study.
All right, thank you, Clark. All right, I'm going to take us through the second half of the study that we put together with Columbia Water and Light, a paper which we'll release after this event. As a reminder, I'm the Policy and Program Manager here at MEI. We're excited about today's event. Just as a quick note, I'll be running things behind the scenes today. If you have any issues with anything or if you have any questions, feel free to use that chat box and question and answer box and bring things to our attention. So as Clark mentioned in the results, what we did see was average annual consumption reductions, which also obviously connected to reduced energy bills for the tenants. So what we did in the second half of this paper is really looked at linking the case study results in Columbia to some of the larger body of research that's been done. Some of that's multifamily housing, some of that's single family, but connecting what some of those impacts are for both the tenants and the property owners. So connecting to some of the studies that Sarah mentioned out of Chicago and Department of Energy, seeing gas consumption costs declines of 25% following efficiency improvements. Looking at Boulder, Colorado's Smart Regs program, which came out in 2010. After initial results, they looked at savings of 23 to 52%, looking at average annual savings of over $300. With our results having average reductions of 25% in energy usage, looking at electricity over $300 and gas at $86, we can see that those results dovetail somewhat with other studies that are out there and show that these improvements can have the opportunity to have a real impact on consumption and, of course, energy costs. Those energy costs obviously will increase disposable income for tenants. That's especially important for renters who tend to have lower incomes than owner-occupiers. And so we can see that they're also going to have increased energy burden. So this has the opportunity to impact that and impact economic stability, as Sarah mentioned. So studies out of owner-occupier properties have shown lower default risks with energy efficiency improvements, 32% lower. And tenants who have lower utility bills, as Sarah mentioned, have more confidence in paying their bills. And this is incredibly important for property owners as well, who are really depending on those timely rental payments. And so money saved on those energy bills can be used on consumer goods and services in the community. And studies have shown that that disposable income tends to stay in the community more than money that's spent on utility bills, which will flow out of the community. So looking at impacts for the property owners as well, obviously, focusing on this split incentive issue, cutting energy consumption is going to impact tenants directly with their energy bill, but it's also going to have impacts to the property owners, as Sarah mentioned. So reducing tenant turnover is a big one. So properties with green certifications have shown improved tenant satisfaction. And studies have found that vacancy rates have been lower for those properties where efficiency improvements have been invested in. Tenants with lower energy bills, turnover tends to be slower in those units. And what you can see here is a graphic. There was a survey done of property owners just showing how often the frequency of turnover costs came up. This is something that internal rental industry data looks at average utility average turnover costs at about $1,000 a unit. That can obviously range depending on where the property is, but this can be a significant recurring cost for property owners. As Sarah mentioned, net operating income and rental income can be increased, right, with efficiency improvements. So there was a study that looked at 10 different cities at rental listings, and those with energy efficiency features had rental premiums from 6 to 14%. Net operating income can increase through increased rental income, and this can come from charging higher rents, or it come from increased occupancy, or a combination of both. And obviously more data that we have in different studies to look at occupancy rate can shed light on what exactly is happening with the net operating income. And what I should have mentioned here is net operating income can impact property value, right? Depending on where that property is and the level of risk and value that the properties around it have, increasing that net operating income can, improve the property value for that property owner. Another way to get at net operating income is looking at expenses. Obviously, reduced energy costs are going to directly impact those tenants who are paying for their energy bills. But property owners can benefit from these improvements through operation and maintenance costs. Studies out there have been somewhat of a mixed bag in the residential rental market. Some studies have actually found increases in repair costs, but some of that has been attributed to having greater occupancy rates. Other studies have found, significant decreases in occupation and maintenance costs. So, this is an area that is definitely ripe for further study. One thing we touched on in our paper as well is the non-economic benefits to the tenants and how this can impact the property owners as well. We didn't go into great detail in our paper, but there's definitely a lot of groups that are doing some really interesting research here. I know Renew Missouri and Missouri Foundation for Health are looking at this issue and doing some outreach around this issue. Energy efficiency upgrades have been shown to improve indoor air quality, improve and create a healthier living environment. So reducing those air contaminants, allergens, symptoms associated with asthma. Obviously, those improvements that are improving ventilation, air sealing, insulation, impact on extreme temperatures can improve health outcomes as well. And these are really significant and important. The more often that individuals have to go to the doctor, have healthcare expenses, it's going to impact their ability to go to work, their ability to go to school, and it's going to impact the property owners as well in receiving those timely rental payments and having tenants who are stable and can remain in their building. Obviously, with everything going on with the current health crisis, indoor air quality is of paramount importance. And so this is an area of focus to look at with these energy efficiency improvements. Lastly, just to reiterate what Clark showed you with the data, small investments can have big impacts. Looking at our study, looking at other studies out there, you can look at $3,000 on down. These investments in properties come with big impacts, reduce consumption, reducing the energy bills for those tenants. So this doesn't have to be an incredibly large investment. When we talk about that low-hanging fruit, it really does have benefits to both property owners and tenants. And so as Clark mentioned, there's definitely room for more research to be done here. And I think that's something we're excited to look at. When we look at occupancy rates or digging into expenses for tenants and property owners, there's definitely a lot more data to get at, and even outside of course, the research we're doing, the research Elevate Energy is doing, there's definitely room for long-term, robust, empirical research for residential rental properties to really get at how to tackle that split incentive and how to reduce that energy efficiency gap between, what's economically feasible and makes economic sense and what's actually being realized out there in the market. All right, so I'm going to go over any questions that we have here. Feel free to enter any